All right, so we're going to go ahead and start working on this challenge problem of solving for the vapor pressure. And so what's going on in this scenario is we kind of have a container here. And in that container, we're going to have an HCl solution. So I'm going to go ahead and draw that in with green. And into that HCl solution, we're going to put in a piece of iron metal. And that iron metal is 2.52 centimeters. Now, when it goes through that process, it produces hydrogen gas, and that gas is going to come bubbling out of our container. We're going to capture it through this tube into another container. Now, what's interesting about this is that this is being captured over water. And so you start off kind of with this whole tube filled with water, and over time, as that gas kind of bubbles in there, it's going to push out the water. And we're going to capture that hydrogen. So that's kind of like the setup of it. Now, what we want to do is we want to find the vapor pressure of the water in ATM. And that's because while this happens at 25 degrees Celsius, then there's a certain amount of vapor pressure that's in the air. Now, I guess this one has a typo. It should say mmHg. So we take 23.80 mmHg. We say 1 ATM is 760 mmHg. Now I'm going to keep 4 of those significant figures, so 0.03132 ATM. And so that's the vapor pressure of the water in ATM at that specific temperature. Going to the next one, we can find the pressure of just the hydrogen gas. So we know that the total pressure is going to be made up of my hydrogen gas, but it's also going to be made up of the water that's captured above that solution. So we can take that pressure of that, or the total pressure is 1.020 ATM. We're looking for the pressure of the hydrogen, and we can take our pressure of our water from above, place that there. So 1.02 minus our pressure of our water, and we get the pressure of hydrogen as being 0.98868 or 0.988 because of our significant figures. And so that's how much of that pressure is just our hydrogen gas. So we need to figure out the moles of it. So we have one scenario, so we can use PV equals nRT. We want to find moles, so N is equal to PV over RT. So our pressure is 0.989 ATM. Our volume, going back up, 2.536 liters. Our R, now you can use the 0.1 or 0.0821. I'm going to use the 8206 because it's more precise. And my temperature is 25 degrees Celsius plus 273.15 because I want to go ahead and convert that into Kelvin. So this kind of becomes 0.989 ATM, 2.536 liters still, 0.08206 liters atmosphere, K mole, and 298.15 Kelvin. So all in all, my N becomes 0.1025 moles. And I'm going to go ahead and keep 3 significant figures because of our pressure. I only have 3 significant figures. Now, it's asking us about the moles of iron in the total sample. So we want to go back and we want to think about how our iron showed up. Now, our iron in this case was happening from our solid metal. And so we're trying to figure out, well, we know the volume of it, but how can we get to our moles? So we know that it's 2.52 cubic centimeters, but we do know the density of it. So we can take our 2.52 cubic centimeters. We can multiply it by the density of 7.86 grams per 1 cubic centimeter. And that's going to give us the grams of our iron. Now, to get from our grams of iron to our moles, we just need to use our molar mass. That there's 55.845 grams of iron, 1 mole of iron. And this will tell us how many moles of iron we have put in from the very beginning. So 2.52 times 7.86 divided by 55.845. So we get 0.3547 moles of our iron. Okay. And so now it's asking us, well, if the reaction follows this chemical equation below, what was the percent yield of this reaction? Well, let's take a look. We had 0.355 moles of iron. So theoretically, it should be 1 mole of hydrogen for 1 mole of iron. So that means that we should have made 0.355 moles of hydrogen. Now this is our theoretical value. Our actual value is our 0.103 moles of hydrogen captured from the experiment. So this is our actual. So a percent yield should be our actual 0.103 moles of hydrogen divided by our theoretical 0.355 moles hydrogen times 100%. So we should be at 29.0%. That's all we kind of need to do it. All right. Hope that helps.